Okay, Physics 11A, it's just a really quick basic forces review. We've got page 33 in the blue review book here, so statics. This is when the net force equals 0. The static situation is when the net force equals 0. So it's important to remember when net force equals 0, that means the forces are balanced. That doesn't mean that the object isn't necessarily moving. It means the acceleration is equal to 0, which means either at rest or moving at a constant velocity. Some kind of grit on my whiteboard here. Oh well. Constant velocity, that means, when the acceleration is 0. So static is when it's a constant velocity. That could be 0 or non-zero. Dynamic is when it's not a constant acceleration. Or sorry, it's not a constant velocity. There is an acceleration in the dynamic situation. So the first bit here is about components and forces, adding them up, all that sort of thing. And really the main thing we do with that is, just like on the top of page 36 here, breaking a vector into its component using SOHCAHTOA. All right, so I'll just look at a basic one there. I gotta just quick clean this off. Let me just pause this here. Okay, back to it. Sorry, the whiteboard was gritty. It was like dirty. Hopefully it's better now. But anyways, let's look at an example there. So let's say we have a 30 Newton force, right? And it's on an XY axis, an XY plane. We call this the horizontal. Sometimes we call this the vertical, the horizontal, the vertical. We usually reference the angle to the horizontal. Ooh, I better not make it 30. I'll make it 35. All right. So this is the force F. The projection of the force onto the x-axis represents its horizontal component, or its x component. I'll call that Fx. And the projection onto the y-axis we'll call Fy. All right. Now those two forces, Fx and Fy, they're not actual literal other forces. Usually we make them as little dashed arrows, the components, right? Made them a different color here so you could see them. And those are called the components of the force. Together, Fy and Fx produce F. In this case, maybe it's a block being dragged across the ground with some rope, right? Maybe that's what is happening here. So if I want to find Fx and Fy, I'd say, okay, Fx equals 30 times the cos of 35. Fy equals 30 times the sine of 35. I jump right to that. As long as the angle is referenced to the x-axis, the adjacent side we use the cosine, the opposite side we use sine. So Fy and Fx. So then you can go ahead and plug and chug those. It's close to 30 degrees. The y component should be a little more than half of 30. Yeah, it's good to have those references in your head, like how they relate. Some stampede going on above me in the dining room there. Okay, sine of 35, bam. So we've got about 25 newtons and about 17 newtons. Now note they don't add up literally to 30, the x and y component. What it adds via Pythagorean's theorem, right? So if you really want to check your work, you have to use Pythagorean's theorem to determine if they actually are adding up correctly. All right? So that's basic components. And sometimes we have to go in reverse, where we know both components. We have to find the resultant and the angle. Often when we have to do that, we'll just make a triangle out of it. We'll say Fx, Fy, F, and theta. All right? So then from there, use Pythagorean's theorem to find F. And then we probably use inverse tan to find y and x. So those are, the basic statics, angled forces, that sort of thing. I want to keep these videos short here. Basic, there's different questions on that page. You have the answer key here. You can check that out. Now, dynamics is F net equals ma, or the acceleration of object is